Hi everyone, in this video we're going to talk about the contrapositive, and then in the next video we'll talk about combining argument types. So in the previous section we learned these two valid argument forms. We learned valid by modus ponens, which you do not have to say or memorize that name. You can just know that this is the correct order. It goes from A to B here. It says if A, then B. So then A happens, which is the first thing, then B must follow. That's correct. And you learn valid by transitivity, which is A goes to B, B goes to C. Therefore, it must be true that A goes to C because there's a chain made from A to B to C. We also learned that arguments can take on many forms. For example, this right here is a valid argument by correct order. Why? Because here's my first thing and here's my second thing. My first thing, which is not B, happens. They're identical. So the conclusion not A follows directly from the premises. It's in the same order. So this is valid. And I've written it out here in a little diagram, but it's the same thing as what I just said. But for this video, what we're concerned with is what if we have this argument here? You notice that the order is wrong, right? But I have a not here and a not here. And so could this still be a valid argument? To decide, we're going to look at something called the contrapositive. So the contrapositive is an equivalent statement, a statement that means the same thing, has the same truth value as A arrow B, if A then B, but uses not. So I want you to try out these sentences to see which of these sentences means the same thing as A arrow B, if A then B. So we're going to call this, if it's a cat, then it's an animal, just to get an example. So A arrow B is, A is cat, B is animal. If it's a cat, then it's an animal. Which of these three sentences means the same thing? If it's an animal, then it's a cat. If it's not a cat, then it's not an animal. Or if it's not an animal, then it's not a cat. So what I want you to do is pause the video right now and see which of these three sounds true to you. Because since this one is true, if it's a cat, then it's an animal, the one that's equivalent has to also be true. So really, really pause the video. Even if you get it wrong, it's okay. Who will know? Try it and see if you can figure out which one is the same. Okay, did you pause? Oh, I hope you paused. So the first sentence, if it's an animal, then it's a cat, is not true because it could be a dog, right? An animal could be a dog, so just not true. If it's not a cat, then it's not an animal, is also not true. Like a dog is an animal, so no. And then the last sentence, if it's not an animal, then it's not a cat, is true. And that's the equivalent sentence. So the deal is that the contrapositive of if A then B is not B then not A. Those two statements are equivalent. The contrapositive reverses directions and has a negative in front of each one. So let's try example 1. Let's see if you can do this one. So if a number is a multiple of 4, then it's a multiple of 2. That's true. So for instance, 24 is a multiple of 4. It has to also be a multiple of 2. So what I want you to do is write the contrapositive, which is where you reverse it and negate each one, make the negative of each one, and show that that's true using an Euler diagram. So again, pause the video and see if you can try that out on your own. So if it's a multiple of 4, then it's a multiple of 2. The contrapositive, so all multiples of 4 are multiples of 2. Just that's the easier way to get your head around the diagram, right? The contrapositive is if it's not a multiple of 2, then it's not a multiple of 4. So you can think of a number out here that's not a multiple of 2. And it's pretty clear that it's also not going to be a multiple of 4 because it's also outside the multiple of 4 circle. So imagine x is 7, for instance. 7 is not a multiple of 2, and there's no way it's going to be a multiple of 4 either. Now try another one. If a number is divisible by 6, it must be divisible by 3. So what I'd like you to try doing is to write the contrapositive in symbols and in words. And if you didn't pause the video last time, really pause the video this time and rewrite it using the contrapositive and think about all those other possible not statements and how you might think they're true, but they're not. That the only one is true is the real contrapositive. So pause the video. So if a number is divisible by 6, it must be divisible by 3, can be written with 6 arrow 3. If divisible by 6, then divisible by 3, or whatever symbols you used are fine. And so when we negate it, it's not 3 arrow, not 6, right? You have to reverse the direction and put knots in front. And that's true because, for instance, if you look at the number 20, 20 is not divisible by 3 and it's not divisible by 6. Another possible version of this statement, if a number is not divisible by 6, it's not divisible by 3. That's not true. For example, 21 is not divisible by 6, but it is divisible by 3. So don't get caught by the wrong version, what's not the real contrapositive. It's also not true that if a number is divisible by 3, it must be divisible by 6. Again, 21, it's divisible by 3, but not by 6. So the contrapositive leads us to this exciting third valid argument form. Here goes. So here's an argument that's valid by contrapositive. A arrow B is the same as not B arrow not A. So if I now next put not B, and then last as my conclusion put not A, the correct order is still being followed. So you have valid by contrapositive by rewriting this in your mind using the contrapositive and seeing that the correct order is still being followed. So now let's try this with a few arguments. So let's see which of these arguments would be valid by the contrapositive. And again, pause the video, take some time to write each argument in symbols and draw an Euler diagram. If you decide you really don't have time to draw the Euler diagram, at least write the argument in symbols to decide, but it's best if you try both of them just to keep practice in your Euler diagrams. So pause the video. And hopefully you did really pause the video. The first argument is valid by contrapositive because the order is reversed and each part of the statement is negated. So I reverse it and put A, it's backwards, right? But I put not A, and then I put not C. So it's the opposite order, and each letter is negated. And the Euler diagram looks like this. All cats are animals, and this X that's out here, this is not an animal, right? X is not an animal, and so you can tell that that makes it outside the cat circle. So the argument is valid. Second argument is not valid because even though we negated, each part of the statement, the order was not reversed. So, and you can see why it's not true because in the Euler diagram, all multiples of 6 are multiples of 3, which is true. We could see that this number here, that's not a multiple of 6, could be either here or here. So it might be a multiple of 3. So the important thing is that the conclusion not a multiple of 3 is not valid because it's not 100% certain. To have a valid conclusion, it has to follow 100% certain from the premises. Okay, so now one more. So let's use the contrapositive to write the statement, if it's a fish, then it's not purple, and create a valid argument. So if it's a fish, then it's not purple, looks like that, right? So what I want you to do is think about what happens if you reverse that with knots. So how would that look using the contrapositive? And what are you going to do with the not not? I bet you remember from the last video. So think about it. So we should have, to write it as a contrapositive, I hope you tried it yourself, turn the statement around and negate each part, right? So then we have not P, arrow F, not F, which is the same as P, arrow not F. Now that you've done that, translated it by flipping it and putting knots in, think about what would be a valid argument that would follow from this statement. So if I have P, arrow not F, what could I put next that would make a true argument? It's like now you're getting to actually create your own valid argument. What would you create? Give it a try. Pause the video. So one possible valid argument is this one here. F, arrow not P, P, therefore not F, because that would follow the exact same order of the contrapositive. Now, that's not the only possible valid argument. You could make a valid argument that goes F and then not P, right? That follows this version of it exactly. So either argument would be a valid argument. And if it's a fish, then it's not purple is the same as no fish are purple. And so we would then say, okay, we have purple, which means we have a purple thing. We put an X here, and sure enough, that means there's no way it can be in the fish circle since the two circles do not overlap. So that's the end of this video. I'd like you to try some of this stuff out before you look at any other videos, just to make sure your practice is up and read a little bit in the book. Bye.